Hello friends, this is me Amorendra Ghosh. Today we are going to learn some important graphs that we frequently come across while studying physical chemistry. I always say that there are two major things that we should learn. One is the mathematics and second one is the physical interpretation for understanding any physical concept in physical chemistry. And graphs play a very crucial role in the mathematics portion. So one is quantitative approach, which is the mathematics, and another is the qualitative approach, which is the physical interpretation. So in the quantitative approach, that is in mathematics, graphs becomes very much important to us. Some special type of graphs we are going to discuss here, but one thing that we should note, it is worth noting that we are not going into the detail of the mathematics. So we are not interested in understanding the mathematics in a very detailed manner. We want to just understand it from a surface level. So without any further delay, let us first see some important graphs. First one is the linear graph or straight line graphs. Second one is the parabolic graph. Third one, hyperbolic. Fourth one, exponential, which is very much important. Exponential. Fifth one is logarithmic. And sixth one is a mixed graphs, which is very much important. One by one, we are going to discuss it. So let us start with the first one, which is the linear graph. Linear. The general expression for any straight line or linear line is y equals to mx plus c. We all know this from childhood, where m implies slope, c implies intercept along positive y direction if it is positive, and negative y direction if it is negative. How it actually looks like if I plot in a graph y, x, so this is the intercept c, and if the slope is positive, then m equals to tan theta is positive. Now slope m equals to tan theta, we can write it as dy dx. We all know that. For our simplicity, we are writing it as y2 minus y1 by x2 minus x1. But we have to very much aware about it that it doesn't imply this. For our simplification, for our understanding, we are writing this derivative into this way. So here we can see that the intercept along positive y direction is positive here, and the slope is positive. If we extend the graph along the second quadrant, it will cut at the minus x direction. So we can also say that this straight line has the intercept, this one, along minus x direction. We don't know that what is the value of this, but if it is mentioned in a question that a straight line with positive slope intersects minus y direction, minus x axis in some position which will mention, then we can follow the mathematics in that way. So let us take few conditions. First condition is m equals to positive but c equals to 0. Slope is positive but intercept is 0. Wow, how the graph will look like? Slope is positive, intercept is 0. That means it will pass through the origin. For positive x value, in the first quadrant we get this linear line. For minus x value, we'll just extend it towards the third quadrant, and the graph will look like this. This is for positive slope. If m is negative and c is positive, sorry, c is 0, then how it will look like? See here, slope is negative and intercept is 0. That means the straight line will pass through the origin, and slope is negative, so we'll have this type of graph. Now one may raise a question here that why we are writing this kind of graph when slope is positive and this kind of graph when slope is negative. We can have a very much brief interpretation to this using this formula. How it will work here: say take any x value, say it is x1, and it will correspond to any value in y1. Similarly, for higher x value, which is x2, we will get a higher value y2. Now if we do y2 minus y1 divided by x2 minus x1, it will be positive. From the graph it is clear that x2 is greater than x1, y2 is greater than y1, so the slope will be positive. So for positive slope, graph with positive slope, we write in this way. This signifies that with increase in x, the value of y also increases. Similarly, when the slope is negative, how this designate this type of graph? For any x value, say for x1 we have y1, for higher x value, say x2, we have this value y2, but here y2 is much more negative than y1, so here y2 minus y1 is negative, but x2 minus x1 is positive, so overall the slope will be negative. So from here, from using this one, we can understand that why we are writing this type of graph for positive slope and this type of graph for negative slope. Another case, let us consider when m is positive but c is negative. M is positive, c is negative. So how it will look like? We've already seen that m is positive but c is negative. That means it will cut in the minus y direction, and m is positive, that means we'll get a graph like this. In a similar way, for m equals to negative and c equals to either positive or negative case, we can draw the graphs using the procedure. So the linear graph questions, I think, is clear to us. In studying chemical kinetics or any other chapter, we frequently find this type of graphs where the notion of the straight line equation is very much important. The second one is parabolic graph. Parabolic. General expression for a parabola y equals to x squared. Again, I am mentioning the quote that at the start of the video I said we are not going into the detail of the mathematics. Just for understanding in for a surface level, we are proceeding this discussion. So when we are saying that general expression of parabola y equals to x squared, it is not actually correct, but for our simplicity we are considering this y equals to x squared. This designate a parabolic graph This is a parabolic equation. Now in childhood we used to do a trick for plotting any graph. We used to write like this: y x, then you used to put one by one the value of x and evaluate the value of y. At first let us consider y equals to minus x equals to minus infinity, so y will be positive infinity. Now suppose x is minus 4, y will be 16, x is minus 2, y will be 4, x is 0, y equals to 0, x is 2, y equals to 4, x is 4, y equals to 16, x equals to infinity, y equals to also infinity. If I plot this one here, how it will look like? Say this is 1, 2, 3, 4, 1, 2, 3, 4, 5, and so on. Now when x equals to 0, y equals to 0, we get this point. X equals to minus 2, say this is minus 2, y equals to 4, so in this point. Now x equals to minus 4, y equals to 16, so the value actually go beyond the board, so we can't show it to you. Similar way, for the positive 2 value, positive x equals to 2 value, we get this value. Now we can surely say that the graph will look like this, and we call it a parabolic graph. Now when y equals to minus x squared, how it will look like? It will be in a upside down manner. That means in that case, when y equals to minus x squared, all the value of y becomes negative. Similarly, for x equals to y squared, how it will look like? It will look like this. And x equals to minus y squared, you can do it from your own. It will be like this. So these are our parabolic graphs. I think it is clear now. Now let us move on to the hyperbolic graph. Hyperbolic graphs. General expression for this: x equals to a, y equals to b equals to constant. Constant, let's say k. At first let us consider a equals to 1, b equals to 1, then y equals 6, y equals to constant k. Now let's suppose k equals to 5, okay, and then y equals to 5x. We will do the same thing as we do it before. One by one we'll put the value of x and y. Say when x equals to 0, y will be infinite, right? When x equals to 5, y equals to 1. When x equals to 1, y equals to 5, and when x equals to infinity, y equals to 0. So how it will look like? It will look like, if we plot it, when x equals to 0, that means it is actually approaching towards 0. Y becomes infinite. We don't know where it is infinite. Now when x equals to 1, say at x equals to 1, y equals to 5, 1 2 3 4 5 here, and when x equals to 5, y equals to 1, and we also get a value x equals y equals to infinite for x equals to 0 and y equals to 0 for x equals to infinite. So the graph actually looks like this way. This becomes asymptotic to x axis, and this portion becomes asymptotic to y axis as it approaches towards 0. It is called a rectangular hyperbolic graph. This is for y equals to constant, xy equals to constant. Now when say a equals to 3, a equals to 2, and y equals to b equals to say 1, then how it will look like? Then the graph actually falls very much rapidly. The y direction graph at lower x value, the graph actually same, but as x increases it falls rapidly. Then we will get graph like this, and then it will become asymptotic towards x axis. So this is our hyperbolic graph. We can have different type of hyperbolic graph after putting a and b, which may be arbitrary and positive integer. Now we have our exponential graphs, very much important. Exponential. Say y equals to a raised to x, or we can say y equals to e raised to x, where this e has got a value from 2 to 3. The value of e lies between 2 and 3. Okay, but for any other value we can say that y equals to a raised to x, where a can be any positive integer. Now how the graph of this will actually look like? Okay, so at first assume any value of a, say 2. Okay, then how it will look like? When x equals to 0, y equals to, that means y equals to 2 raised to x. When x equals to 0, then y equals to 1. When x equals to 1, y equals to 2, 2 equals to 4, and when it is 3, 2 raised to 3 means 8. Now when say when x equals to minus 1, it will be 1 by 2, and we plot it y x. Okay, when x equals to 0, y has a value of 1. When x equals to 1, it has 2. When x equals to 2, it has 4. So it is a exponential graph. This graph looks something like this, and at the negative x direction it becomes asymptotic towards the negative x direction. Asymptotic means at minus infinity it will meet at y value, but we don't know actually what is infinity mean, what is actually infinity, what does it actually imply. So we call it that asymptotic towards that direction. Okay, in which direction it will meet at infinity. This is for y equals to a raised to x, or you can say y equals to e raised to x. We will get similar kind of graph. When y equals to e raised to minus x, how it will look like? Okay, in that case we'll have a graph like this. You can try it your own, that how it is happening like this by doing similar algebra. Now let us consider another condition, y equals to e raised to minus x square, which is very much important graph. Okay, let us do the similar thing as we were doing before. Say x equals to minus x, y equals to 0, then if x equals to minus infinity, then it is e to the power minus infinity, which is actually 0. So then say x equals to minus 4, then it will minus 2, say, then x equals to e to the power minus 4, x equals to minus 1, y equals to e to the power minus 1, 0, 1, 1, e to the power minus 1. Similarly, plus 2, e raised to minus 4, and infinity at infinity, it will be 0. How the graph will look like? This is very much interesting actually. This is y and this is x. For x equals to 0, y equals to 1. Okay. Now, when x equals to 1, the value gradually decreases and it falls exponential actually. Similar thing happens for the minus x direction. Hence, we will get this kind of graph, which is known as Gaussian graph. So, y equals to e to the power minus x square corresponds to this type of graph, which is called Gaussian in nature. So this was our exponential graph. Now let us move on towards the logarithmic graphs. In logarithmic graph, logarithmic graph say log x base a equals to y, where x is called the argument. We know actually, we all know it, and a is called base. Now if base a is positive, then the graph look like this. How it is happening? How it is something like this, we actually not interested in. Here we just ignore it, what is happening here, and let us by heart it. Okay, the graph is something like this, but when a is negative, then the graph look like this. Sorry, the graph look like this. This is y and this is x. This is the logarithmic graphs. Now let us move to the most important part, which is the mixed graphs. Okay, take this example, y equals to x e raised to minus x. Okay, how we will now proceed? Okay, let us first write it as e raised to x. So we know that if y equals to x, how the graph will look like. We know y equals to e raised to x, how it will look like. Then if we combine these two graphs, we will get this resultant graph. Okay, so we will not do the previous thing that we will put a value of x, then get the value of y, plot it in the graph. We are not going to proceed this procedure. Rather, we will divide it into two separate equations whose graphs are known to us. Then after that, we will combine these two graphs, and the final graph will correspond to the mixed equation. So say this is y1 equals to x and y2 equals to e to the x. how this actually looks like. We know that it will look like this. And how this one look like? This look like this. Now if we combine these two graphs, now become very much serious here. Here the value is positive and corresponding y2 value is much more positive. Similarly, here the value of y2 is positive corresponding to x value, but for the exponent's term the y value is again much more positive. If I then combine these two graphs, we'll get very much closely actually here, because here it is 0 and it has got a value. If I combine these two graphs, it will turn out to be 0. Now here we see that this value actually in fraction, when it approaches to minus infinity, this is minus negative, but it is something like 0.0000, and after many 0 it contains a value. So if I multiply it, sorry, here it is positive, so positive 0.00000, where it ends we don't know, and then it contains a value, say 5. So this value is very much less compared to 1, and if I multiply with a very much negative value, it will further decrease. The value will be further decrease and it will contain negative sign. So we will get a value like here, like this, and then it will tend to increase. Now let us do some mathematics here. We don't know that what will happen in between these two. We have understood this, that how it is following this kind of graph and why this is happening like this, but we don't know what is happening in between them. We will do derivative dy dx. So x e raised to x and e raised to x and 1. So e raised to x, 1 plus x. We have got this one. Now let us do d2y dx too. So e raised to x, 1 plus x, and e raised to x. So e raised to x, x plus 2. Now for a minimum and maximum value of y, dy dx equals to 0. So let us write this one 0. E raised to x equals to 0 or 1 plus x equals to 0. If e raised to x equals 0, that means x equals to minus infinity, which you know that will happen from the graph. But x equals to minus 1, for x equals to minus 1, there contains a there is a minimum, minimum or maximum. Okay, if I put x equals to minus 1, then 1 by e, it will be 1. So this will be positive. That means there will be a minimum here at minus 1. There will be a minimum like this. So the combined graph y1 equals to x and y2 equals to e to the x, that is y equals to x e raised to x, will look like something like this, So this procedure is very much helpful, you can see. Now let us take another example. Say y equals to x e raised to minus x square. So how it look like? Okay, let's suppose y equals to x square e to the power minus x square. Y equals to x square look like this. We have previously seen that it is a parabolic graph. and e raised to minus x square is a Gaussian curve. Okay, so this is for y equals to x square, and how the Gaussian curve look like? It looks like this. So this is the y1 and this is y2 equals to e raised to minus x square. Now if I combine these two graphs, see here the value of y2 is much more positive and here the value is very much small. Okay, now move here, these two will combine and it will become greater in magnitude. Here 0 and 0, it will pass through 0. Okay, similarly here it will be positive in value. So the finalized graph will be something like this, if I'm not wrong. Sorry, if I combine these two graphs, it will be something like this. This height will be same, so it will be something like this, if I'm not wrong. Okay, you can see that here when it approaches to minus infinity, the first one, that means the Gaussian curve, when it will when we multiply with the greater y value, here the value of y is much more greater, then the combined value will be very much less, so this will decline very faster. Now with when the x value minus x value approaches to 0 and then we combine the graph, you can see that here after combination it will take greater magnitude, and similarly here also at x equals to 0, y equals to 0, and after that whether it is positive x value or any minute change in negative x value, the value will be much more greater here, so it will follow this kind of graph. So this was our brief discussion about the important graphs. I think it is much more clear now for all of you that if any expression is given to you, how you will write the graph corresponding to that expression and how you will interpret the graph. So that's it for today. I hope this video will be very much helpful to you. See you in the next video. Till then, take care.